This game incorporates the following concepts: primary and secondary game concepts, whiteboxing and level building, character movement, Unreal Engine enhanced input system and input mapping, gameplay framework systems, game mode, game state, player controller, pawn, player state, materials and material instances, cameras, lighting, sound effects, and particle burst, heads-up displays, user interface widgets, win-lose conditions, and building the game. So let's launch Unreal Engine, and we'll use one of the templates. So we'll go to the Games tab and pick the blank template. There are numerous templates that have added functionality and coding for a particular game that you might be interested in making, but we're going to start from scratch. So we'll choose blank. We'll keep the defaults, blueprint, desktop, and starter content. We'll name our game. And it's going to store it in the default Unreal Projects folder that was created when you install the engine, unless you select a different folder. So you can browse for a different folder to put this project in. We'll say create, and it will relaunch and show you your editor interface and viewport. So it's given me a default level, but I don't want to use that level, and I don't want to start eliminating things that I'm not interested in using. So I'm going to create a new level for my game. File menu, new level. So I want a basic level, which will only have a few elements in it. I'll say create. And the basic level includes a lighting setup, a floor, and a player start. So that's good. So I will save this level, but I don't have a folder for this, so it's just giving me the default. It's giving me starter content and a few other things. So I'm going to use best practices and good file management, and I'm going to create a folder for maps. Right click, new folder, we'll call this one maps. And now I will double click inside maps, and I will save this level. So map and level are interchangeable. File menu, save current level as, and now where do I want to put this? Double click in my folder maps, and we'll call this ball play level. You can name it whatever you want. So I'm using what's called camel casing here. That means I'm using initial caps to separate out the words. You could use underscores. It's not always a good idea to leave spaces in your names when you're working with an engine like Unreal or other gameplay engines. Microsoft Windows is very good with leaving spaces, but it's not always functioning and can create problems. So using camel casing is a good best practice to follow. So this name is using camel casing, and if I click save, I now have my level in here. So I want to go back up and now start to create my game. So there's something interesting when I use a template. It has what's called a gameplay framework in it. So a gameplay framework is a selection of classes that work together to make a game function. If I go back to my engine, if I click play, I can see there's a lot more objects that are added into this playing command that I executed. So why is that? What are these objects that are in here? Well, it's helpful to understand object-oriented programming and a little bit of really Cliff Notes history of how we got to using object-oriented programming, what it is and how we got here. So very simply, computers speak in on-off electrical current switches. So it's numerical. It's either 1 or 0. And those patterns create things that can be communicated to humans. So if you wanted to say hello directly to a machine, you would have to say 10111011, whatever that is, and it would take so long it wouldn't be effective. So over time, assembly language was added on top of machine language to kind of coordinate the patterns so that humans could use and control what happens on the machine. And then we evolved to procedural programming. So procedural programming is a list of step-by-step instructions, procedures that create something. So you could have numerous step 1, step 2, step 3 that are happening in your program, whatever you're trying to do, but it's still a little bit cumbersome for the average human to understand, because we communicate with the world around us, and we think in terms of objects, the objects that are around us. So for example, if I walk into a room and it's hot, I don't say, give me air, give me air. I say, turn on the air conditioning. So those are two very different ways of communicating, but they're basically saying the same thing. So object-oriented programming was developed to combine and compile listings of objects that are also called classes or templates that can be used and reused and edited. And there are some formats to object-oriented programming. There's some polymorphism, which is, one thing can be many things. In games you find that often, that one a gameplay function can be used for multiple characters. You have encapsulation, so having a user interface that requires a password that's encapsulating, protecting some data. So there's functionality and formatting to object-oriented programming. And Unreal Engine is a C++ software-based program. So it's running off of C++, which is object-oriented programming. These languages, these object-oriented programming languages, have what are called application programming interfaces, which are collections of classes, thousands of classes, objects, that can be reused so that you don't have to start from scratch every time you sit down to write something. So we don't have to do some core C++ programming to just even use our interface when we're using Unreal Engine. So fast forward a little bit. So we're using object-oriented programming, and each one of these objects has been given to us because it has functionality to make a game work. And it knows all the connections that it has to these different classes. So we don't have to recreate the wheel. We don't have to start from scratch. So that's what a gameplay framework is. It's a collection of classes that work together. So if we look at the classes that we're going to be using, they include the game mode, the player controller, the pawn, the actor, and player state. So the game mode is spawned at the start of the game. It initiates the game, and it has some basic functionality that sets in motion other things that have to happen. So it spawns in a player controller. So the player controller is just the intelligence behind that object that you control as you play a game, which is, in the world, a pawn. So your player controller can have a list of functionality that you can use throughout your game. And we're going to create a tab input, which will respawn the player. We'll use the backspace input, which will reload the game. This player controller will possess a pawn, which will be our character. And other things can happen. So your player state, which is also spawned in, holds all the information of what's happening in the game. So if you have collectibles, it will know how many collectibles you have. If it will have lives, it will hold all the actions in the player state so the player knows what's going on around him or her in the game. So this is your gameplay framework. And we're going to build on this. So this game will flow like this chart. So we'll have a start, which will be a title screen, and we can have a couple of selections. So if we start the game, we'll have a process. So our objective is to collect points. and we're playing against a timer. So if our timer gets to 60 seconds and we haven't collected enough points to win, we will lose the game, and then we can restart and go back here and do this over again. If we collect 12 points, which is our objective, we win the game, and then we can either quit or go to the next level. So you can have a flow chart of what's happening in your game. So now we know what we want to do. Let's go into Unreal and start to create this. So I'm back up in content, and I need to make these classes specific for this game. So I need to create some blueprints and then replace them in the gameplay framework. So I want to right click, new folder, because we're following best practices. And we'll call this one blueprints. We'll double click, and there's 3 blueprints we're going to choose from the start. So the first one is game mode base. So we'll call this ball game mode. And the second one is player controller. We'll call this ball player controller. And the third one is pawn. We'll call this ball. So right now I have these 3, and they're not doing anything because I need to now set up the connections so that it knows which blueprints to actually look for. So let me do a file, save all, and the first thing I'm going to do is go into world settings and choose the game mode that I just created. So game mode override is going to select this game mode over the default one that came with the gameplay framework. So now I can see ball game mode is now my game mode, and that's what I want. The next thing is I can open up my ball game mode and choose my other classes in the ball game mode. So the ball game mode is now setting up and initiating some other functions. So we want our player controller class to be our ball player controller. We want our default pawn class to be our ball pawn. And this time we're going to compile and save this blueprint. So now if I play, I will see these 3 classes replaced with the blueprints that I just created, and that's correct. That's what I want. There's one more thing we can do to set up here, and it's connected to the level. So if I go into project settings and I click on maps and modes, I can set up my startup map and my game default map. So this can be done at any time, and we actually don't have our default map yet, but let's just do this so it's set up so we understand it. So there's 2 default maps. There's the editor startup map and there's the game default map. The difference is the editor startup map is the level that starts up when I launch Unreal Engine, the editor part of Unreal Engine. So I don't want to have the open world any longer. I want to have my ball play level. So if I closed out of Unreal and I open back up, this level will open up, so I don't have to switch levels. It saves me a step. The game default map is the map or level that opens up after the game is built. So that's the start map when you're playing the game, a built version of the game, not the Unreal Engine editor. So we don't have a map for this yet. This will be replaced with a start screen. But for right now, we'll just make it the same. And for project settings, you don't have to save these project settings. I'll just close this. And it can be edited again later on. So now let's go into our ball pawn and make our player. So I'll start with adding a sphere in here. And I want to make my sphere the default scene root. So I'm left mouse clicking and dragging on top of scene root just to clean up this hierarchy so it works a little easier. Now I could go in and add a material on here or a static mesh, but this is the whiteboxing version, so I'm not going to get into materials or any of that information just yet. There are a few things I do need to set up on this ball. One is simulate physics. So I want this ball to be influenced by the physics engine. So I need to check that on. I can also include inputs, which we'll add later, the WASD keys. And the second thing here is I want to use my collision presets. So collision presets, and choose pawn. So again, there's some already existing code and functionality that will work. And the last thing I want to do is select the ball pawn self and go up and auto possess player. So we want to have this control the player 0. Now if I compile and save, that's the start of this. But if I hit play, I don't see anything. So I've launched the ball pawn class blueprint, but I don't see anything because there's no camera connected in my setup. So I need to add two things. I need to add a camera and something that connects the camera to the object. So the first is a spring arm. So if I type spring in here, it'll show me spring arm. And then connected to the spring arm, I want to add a camera. So I can see there's a camera and there's a spring arm connected to the ball. So if I compile and save, I will see this ball now. Boom. But it's looking straight on. So this is not a great view for gameplay. So I want to change that. So I'm back in my ball pawn blueprint. Where it says spring arm, I want to create a target offset. So I want to offset this. So I'm going to go in Z, which is up. So I want to move this up. So we'll go up 800 units. And target arm length, let's make this a little longer. So we can see it's up, but the camera's still looking straight forward. So in the camera, I want to rotate this down. So this is the y-axis, so we want to rotate around y. So I'm going to rotate negative 40 degrees around y. And now my camera is looking down on my object. Compile, save. Now if I play, I can see the ball, but I'm looking down on it. And this is a better viewpoint for gameplay. So the next thing I want to do is add my WASD controllers, and I will need to create some blueprints for this also. So in my content folder, I will create a folder for inputs. New folder, name it inputs, double click. And there's two things I want. There's two inputs that I want. Input action and input mapping contacts. So I will choose input action, IA, and we'll call this move. So that's how we're going to move around with our WASD keys. Right click, input, input mapping context, IMC, ball. So this is the context in which I'll move this object around. So let's look at that. So your pawn is looking for information, so you can have various actions in a map, and there can be various maps that reuse actions in different scenarios. So the pawn listens for actions it can take in the game from a map. So when we look for move, it responds and it executes the code that's in that move map. So there's different movements that you can use, and they're kind of connected to the inputs devices that you have. So let's go back and look at these options. So a digital bool is an on-off. It's one or the other, true or false. So this would be a tap, a button press, something like that. An axis 1D float is a one-dimensional axis that ranges from -1 to 0 to 1, X or Y coordinate. So if you had a joystick, this would go back and forth. That would be an axis 1D float. Axis 2D or vector 2D, this is a two-dimensional axis with X and Y coordinates. So you have the option to go positive Y or negative Y, positive X or negative X. So in our case with the WASD keys, we want to move around on a flat plane in one of these coordinate systems. And then there's axis 3D vector, which uses three-dimensional axes, X, Y, and Z coordinates, and this would be for camera movements or camera situations. So in our case, back in the engine, we need to determine a value type. So which one of these types of moves do we want to use in this action? So we want to use the 2D vector. So we want to be able to move around in an X-axis and a Y-axis. We're not including the Z. So I'll save this, and we'll close this, and we'll go into the mapping context. And here we want to choose our WASD keys. So the first thing we need to do is to pick our map, our input, and now we have 4 options. So the first one, we can just type in W and it'll find the W key. Going to select another one. We'll find the A key, and we'll find the S, and the D. And we'll save this. So there's a couple of settings in addition to these keys that we need to include, because if I put an object in here, so let's look for shapes. So my orientation here is X, Y, and Z. So X is the red arrow, Z up is the blue arrow, and Y is the green arrow. So if I look at my orientation, so if I move in X, I have a positive direction and a negative direction. If I rotate in X, I'm actually rotating sideways, not forward. So to compensate for that, I would have to rotate in the Y-axis. So if I wanted to move and rotate in the same direction, my movement would be in the X, but my rotation would be around the Y-axis. So this kind of thing happens, and it can be adjusted by the settings that we use in our mapping context. So our modifiers, so for our W key, we want a swizzle modifier. So the W key is moving forward, so we want to swizzle this input axis. And also we want to make sure that our rotation order is Y, X, Z and not X, Y, Z. So we're moving in, Y first, then X, then Z. My A key needs a negate because the A is moving sideways. So we want to make sure that the positive is the negative is the positive. So this is going to switch it. The S is the same as the W key. So we need a modifier for that because that's the reverse. So we need to swizzle this input, and we also need to negate it. And the D key is fine, so I can save this now and have the functionality for my mapping and my movement. So let's do a file, save as, and now we can connect this to the pawn through a blueprint. So let's go into our blueprints folder, open our ball pawn, and in the event graph we're going to add instructions to connect our input system, the WASD keys, to the movement of the ball. So in event begin play, that's where we're going to start, and we want to get controller. So we want to cast this to a player controller. So casting allows you to take a generic object and connect it to a specific object to find certain variables and information. And now we're going to look for our enhanced input system. Get enhanced input local player subsystem. And from here we want to find our mapping contacts. Add mapping contacts, and we will select the IMC ball, which is the mapping contacts we created. So, and in between here, we're just going to put a check is valid to make sure, to make sure the object hasn't been destroyed and it exists, and then we'll follow through here. So now I want to just close this up by adding a comment around this section of code, and that's a good best practice habit to leave code nice and clean and organized so anyone can go in and see what the code was intended to do. So if I hit the C key, it will give me the ability to put a comment. So we're adding our mapping to the pawn, and compile and save. So we can test this to see if now this mapping contacts is usable in the gameplay in the viewport. So if I right click and look for my move, IA move, we want the enhanced action event. I can test this using print string. So when this is launched, we want to print string. And we're not looking for words to print to the viewport. We want to see if our action values can be printed to know if this connection is actually functioning correctly. Compile and save. Now if I go and play, I should see my WASD keys giving me numbers. So when I hit the WASD keys, it's giving me the coordinate values for those vectors. So those X and Y vectors, where the ball would be positioned once we connect the ball. So we can remove the print string because this is functioning. And we're now going to elaborate on the action value. So if I right click here, I can split this struct pin to specific values, X and Y in this case. And we're going to multiply from here, -1, so we're oriented correctly. And then we're going to make this a vector. Make vector 2D and connect our Y. So this will give us our X and Y points to do our vector. And now we want to just clean this up. So we're going to normalize this vector length, because if you draw a vector straight and at a diagonal, the diagonal line could sometimes be longer. So we want to make sure that the length is the same no matter which angle it gets drawn at. So we'll normalize here. And now we want to give this some roll movement. So we need a variable for that. So we'll create a new variable and make sure that it's float. Float is decimal points. And we'll call this roll torque. And if I compile and save, it allows me to give a default value. So my default value is going to be rather high for momentum. So now I want to be able to multiply by this, variable. So we'll have another multiply node. We'll bring our variable in, left mouse click, drag in, get roll torque. So we're going to get this torque number. and we want to add it to our actual object. So now we'll bring in the sphere, and we'll find this torque. So add torque, and we want to choose radians because it's a little more accurate way to determine the angle rather than degrees. So it's a smaller number. It's a more scientific method to determine the angle here. So we'll connect the multiply to our torque, and connect our triggered to the torque number here, and compile and save. And there's one more thing. So this spring arm needs to be in a world rotation. So if I don't change that, it's going to flip. So if I hit the WASD keys, it's going to flip around. So that's the difference between relative and world. So we want to change from relative to world, compile and save. Now if I play and I hit my WASD keys, my ball will move. There's the W key, there's the S key, there's the A key, and there's the D key. So it will move around. So the code is now working, and I have a player controller. And I'm just going to do one little cleanup step. So we'll go back in here, and we'll create another variable, and we'll call this max angular velocity. And we want this to be a float. Compile and save. And we'll drag in our sphere component. And we want to set max angular velocity in radians. And we're going to bring this up over here. And we'll bring in our new max angular velocity. And this is connected into our new max angular velocity tab. And we'll set the default to 10. So this is going to cap the max speed that the ball will roll, so it doesn't pick up speed and go so fast, and it is hard to control. So if I close this out, compile, save, and play, you can see my ball is a little bit more under control. It's not picking up so much momentum as it goes forward, so it's capping it at that number. So I now have a player controller, a ball that can be oriented with the WASD keys, and also can Let's create a collectible for our game. In my content folder, I'm going to create another subfolder, call this one collectibles. Double click inside this folder, again following good best practices, good file management and file organization. Right click, blueprint class. This time we want an actor blueprint. So an actor is an object that can be placed or spawned into the world. It's different from a pawn because the pawn can be possessed and receive input from a controller. So our player pawn gets input from the WASD keys. So the actor will not have that kind of input, but actors can have functionality. So we'll create an actor, call this collectible. And let's go in and add a look and some movement to this object. So in my components tab, I'm going to add a cube. And I want to change the size of this cube. So in my scale, if my lock is on, all three of my attributes will change at once. So my X, Y, and Z have now scaled down. And I also want to add a collision box around this. Add box collision. And I want to make the box collision the default scene root. So now the cube will be under the box collision. I want to make sure that when an object approaches this and goes through the collision box, that it doesn't stop. So I need to set the collisions on the cube. And if I scroll down, there's a tab for that. So my collision presets, I want to have no collision. So I want the object to be able to go through this completely. So once it goes through, then it can follow the instructions that are on this object, and it can destroy. It can be set up so it will disappear or destroy itself. So I also want to have this move around itself, so I'm going to add a rotating movement. And we'll just have this rotate around itself in a stagnant position. So it's going to stay in one place and rotate. Compile, save. So we can bring this into the scene and look at it. So there's our player start. So let's drag this right in front of our player start and play and see what happens. So the object is rotating around itself. And now if I move forward, it will go through the object. So it's set up now for some instructions. Double click to open it back up again. I'm going to put the instructions onto the collision box. So on component begin overlap. When something overlaps this collision box, what do I want to happen? So I'll start the coding there. On component begin overlap, when it overlaps with the player controller, so we'll say if it equals a certain object, so we want to find the player pawn. So if it equals the player pawn, then we want it to do something. So it can be true or false. It can have an option. So we're going to branch this section here. So the condition, it's going to be either true or false. So other objects can go through this, but we're looking for the one that's the player pawn. So if it is the player pawn, then we'll give it some further instructions. So we want to add a collectible count. And collectible count, that should go on to the player state. So we don't want to put the collectible count on this object or another object, because if it disappears, then the collectible count will disappear. So we're going to isolate that information onto a player state. So let's compile and save this and go back to our blueprints folder, and now we need to create a player state blueprint. Right click, blueprint class, and this is in all classes. Player state select, and this is ball. So now we have a ball player state. So we'll compile and save this. Now we need to make sure that the ball player state is red when the game starts. So that is in the ball game mode. So if we double click our ball game mode now, we'll look for player state class. We want to choose our ball player state. And in our ball player state, we're going to open up the full blueprint graph. And we want to create a variable called integer, called collectible count, and this will be an integer. So this ball player state is going to hold the collectible numbering. So we want this to be an integer, compile, save, and we'll leave the default value at 0 because this number will add up. So we'll close this, then we'll go back to our collectible. So we can test this with another print string command and then destroy itself. So we want to print string and then destroy actor. So when it overlaps, we want it to destroy the actor, do the collectible count, and destroy itself. Let's click play. So it destroys itself, and it gave us a comment. We can put collect in here, so we'll replace that later. So a number will then go in where it says collect. So that's functioning. So let's take this print string out. And we want to get access to our player state to find out where we are with our number counting. So we want to get player state. And cast to ball player state. So again, we're using a generic object to find a specific object information. And then from here, we want to get our collectible count. So get this variable. And then from here, we want to add a number. So we're going to use our operators add, and we'll add 1. So if this is true, add 1 and then destroy the actor. So after it adds 1 to the collectible count, it's going to set that as the new number in the player state. So from as ball player state, again, we want to set our collectible count. Set collectible count. And this will come in here. And that's our new collectible count. So to test this, before we destroy the actor, let's just add a print string. Print string. So we're going to alt-click to break this connection. So let's just see if this is working in here. So it will print it to the viewport. It won't destroy itself, so we'll have to reconnect that, but let's make sure it's working. And we see 1. So let's now add a few more of these collectibles. And you can drag the object in from the content folder, or you can duplicate what's already there. So I'm going to Control D and just duplicate a few of these. And let's see if it adds it up. So it's now adding up my collectible count. Let's now add some sound effects and some particles to this collectible object. And we're going to create folders for these. So in my content folder, I'm going to create a new subfolder and call this one audio. And double click in here. And now I need to access an audio file. So there are numerous websites that you can use where you can download royalty-free sound effects. Mixkit.co is one that offers free sound effects. Things like that. BFXR.net gives you an interface that you can use to edit your sound effects and then export out a WAV file. Pixabay also offers some royalty-free sound effects. And sfbgames.itch.io gives you an interface to create your own sound effects and export out a WAV file from the sound effects that you create. So there's numerous options if you can't create your own sound for your game, and they're a lot of fun. So I think this one will work well. So we'll just click the download button, and you need to drag this right into your Unreal Editor. So we're going to do this, and then we'll give it a shorter name. So we'll call this Collectible Sound. Now on here I need to create a sound cue, which allows me to do some extra things to this, like adding a modulator, which will randomize the sound each time it's played. So in this blueprint for the sound cue, right click, modulator, and when the sound is launched, it's going to go through a modulator to the output, and we'll save this. And now we need to connect this sound to our collectible blueprint. So we'll go back to collectibles, double click, and after our print string, we want to play our sound at a location. So right click. So we want to use play sound at location. What's the location? We want to get actor location. So it's going to play the sound that we just created. So we're looking for our collectible sound cue, and it's going to play it at the actor's location. So if we compile and save this, the other assets will automatically update. And you can hear the modulator. So we can do the same thing now with particle bursts. So let's create a folder, another subfolder for particles. And we'll double click in here, right click, and we want to go into FX and choose a Niagara system. So these are the default particles, and there's numerous ones in here. I think probably the omnidirectional burst will be a good one for this. So we'll create this, and we'll call this, so we can easily find it later. And you can edit these. If I open up the asset, it will show me the different features, and you can go in and start adding colors, changing the length of things. And particles are very intricate. There's a lot of details that you can edit. So it is an editable file. But now we want to connect this particle burst to the same blueprint. So we'll go back to collectibles, double click, and we want to spawn our particle system. Spawn system at location. So here's our particle system, and this is our collectible P, and we can copy our actor location and put this in here. Compile and save. And now this will continue. When it plays the sound, it will also launch a particle. So let's count up our collectibles now, and we're going to need some user interface widgets for this. So I'll create a specific folder for user interface. right click, user interface widget blueprint, and we want a basic widget blueprint, WBP player info, and we'll open this up. Widgets allow you to work in a 2D view where you can bring in images and text, and also a graph and editor view where you can put coding information. So we'll go back to our designer view and set up our viewport. So the first thing I want is a canvas panel, and I can drag this into the viewport or the hierarchy. It will update in both places, and it is connected to your screen size. Then I can do things like bring in an image box for sprites or text information. So if I wanted to have a sprite in here, there's a brush setting that allows me to import file. In this case, we want to connect to text. So I'll bring in the text box. And a text box can hold letters or numbers, and we want to connect this to our collectible count. So we'll put numbers in here and bind them to the collectible count information. So here I need to get my player state. So we'll do a casting step, starting with a generic class to the specific class, so we can find our collectible count information. And that would normally be output here. But we can replace this casting step with a caching step so that it only runs through and calculates this once and holds that information in a variable. So we'll do that. We'll cut this information and go into an event construct and connect this. And we want to promote this to a variable. So we'll call it ball player state variable, compile and save. And now I can call on this variable to find that information for me. So get player state, get our collectible count, and bring this into our return information. So this now can be brought into the viewport. So if we go back into our blueprints and open up our player controller, we want to create our widget, find the one we just created, and then add this widget to the viewport. So it can be seen. Compile and save. And now we can go back to our collectible and remove our print string information because we no longer need that. It is now going to be connected to the collectible count screen. And let's make sure that we destroy the actor when we're done. So now our collectible count is adding up on our play screen. We can set a temporary win condition to start to add some more gameplay function in here. And if we go back into our collectible object, we can create a scenario where if the count reaches a certain number, it can then launch a win screen and the player can win the game. If not, it will continue to play. And in this case, it will play against the clock. So if the clock gets to a certain point, then the player will lose. So from here, Let's create another variable for win count. And this would be an integer variable because it's a number sequence. And if we compile and save, we can set the win count number that we want. So we'll compile and save, and it can be any number to reach. So 13 is pretty easy for a demo. And then we can bring this win count in and get the win count. And if the win count equals a certain number, which is 13, then it can play, it can go to the screen. So we'll put this information out here. So when it adds up and it gets to 13, that is the win count. And we'll branch this off. So if this is now true, it will win. So we can test this. We don't have a win screen yet, so we'll print screen and we'll have it say you win. And if it's false, it will follow through and just keep counting. So let's go back in and let's put 13 objects in here. And this is a whiteboxing version, so we're not going to do too much with level layout until all of our coding is functioning. 1, 2, 3. So if we play this now, it's going to collect all of these objects. And it says you win. So our win screen, our win scenario is now configured. And later on, we'll replace this print screen with our win screen widget. And it's probably a good time to clean up and put some comments on here. So let's put these together. Comment. So When the player pawn overlaps the collision box of this collectible object, it's going to get the ball player state, which holds information in a variable for a collectible count. Then it's going to add a number to that collectible count. Each collectible that gets overlapped is going to increase the collectible count by 1. And when that collectible count gets to 13, which is our win count variable, and because it's in a variable, we could change that later if we wanted to create some different gameplay, then it's going to branch to a win screen. And if it's not at that win count number, then it's going to continue and loop and go through this process again. So that's the logic behind the coding, and this works. So for a lose scenario, that will be connected to a timer, and that will be set up later on. So we'll continue to add functionality, and the next thing we can do is create a reload level option. So we need to have a mapping context and a move feature. So if we remember our gameplay framework in our player controller, we have inputs, and those inputs will launch different events that happen in the game. So we want to have a backspace input and connect that to reloading the game. So to set that up, we'll go back into our inputs, and we'll create 2 new inputs. IA really low level, and a context for this input. Ball game. So in our input, because this is a button press, the value type is a digital bool. It's either pressed or not pressed. And the triggers we want to know is what kind of information from this button press are we looking for. So we're looking for a pressed. You can see there are other options, but what we're using is pressed. So that's set up now. And in our mapping context, we need to find this action. So that's reload level. And what do we want to connect it to? We want to connect it to the backspace key. So now we can go back to our ball player controller and find that information and set it off when the backspace key is pressed. So we'll look for we'll get our enhanced input local player subsystem. This will refer to itself, so get a reference to self. And then we'll find our mapping context that we just created. So this was the ball game, and this will go at the end of this add to viewport flow. And now we can test this with a print string. So let's find the action. So IA reload level, and when this is triggered, we want to print string, and we'll say reload. Just to check the functionality, and if it works, we can go back in later and replace that information. So my game is playing normally. I can move around, and if I want to reload the level, I hit the backspace key, and it says reload level. So that's set up now, and that's working the way it should be. Let's now create a function for this so that we can replace that print string and call a function. So we're going to go into ball game mode and create a new function. Call this reload level. And we're looking for get current level by name. And we want to open level by name. And our level name is our ball play level. ball play level, that's our map. And now we're going to go back into our player controller, and we're going to replace this print string. So we want to call the function. So we need to first get our game mode and then cast it to our ball game mode. So we're looking for specific information here. And from as ball game, we want to call our function. So now we can remove our print string here and call the function to reload the level. Compile and save. So I'm playing the game and I'm collecting a certain amount and I'm a little bit off course, so I hit the backspace key and it starts over again. So it reloads the level. Backspace key and it reloads the level. Now we can create another event, a respawning of the player. So respawn will destroy the player and respawn it back to the original spawn point, but you can keep the collectible count where it's at. So the collectible count will remain, but the player can be respawned from the start. So the player controller will listen to a new input action, which is a tab key, and then tell the game to respawn by grabbing the spawn point and resetting the player. So this is now our tab input for respawning the player. So we need to create our inputs again, and we'll use the same mapping context, but just create a new action. And we'll have input, IA action, respawn, so this is a digital bool, and this is also a pressed action. And now we'll go back to our ball game context and add this mapping. So here is our respawn, and we want to use the tab key. So now we'll go back to our ball player controller and test this action the way we did the other one. And we'll print string for this and type. So we'll check that the initial inputs are set up correctly, and we'll play. So I'm moving around and I hit the tab key and it says respawn. So that's correct. So now we'll create the functionality, and then we'll put that functionality into a specific function. So we're going to open up the ball player state, and we'll add a variable here, call it spawn point, but this variable type is a transform. And we want to get our player pawn, and get our actor transform position. So we want to get and set our spawn point here. So now in our ball game mode, we're going to create a function for our respawn player. And we want to get the player controller. Get the controlled pawn, check to see if it's controlling anything. And now we want to create a branch. So if the player controller is controlling the pawn, then we want to destroy the actor and reposition it at another location. So destroy actor. And then we want to restart our player at the new transform position. So we'll get our player state to find that information. So we're casting, we're going from the generic to the specific. So our player controller so when we find our new spawn point, that's going to be where we restart the player. And our false option is here. And we're also going to destroy the actor. And now we'll open up the ball player controller. And we're going to replace this print string. Get game mode. Cast to ball game mode. Remove our print string. And then respawn our player. So we're playing, and we hit the tab key, and we've kept our collectible count, but we've reset our player back to the same position. So if we go off a little bit, we still have a player count. And tab, we're respawning back to the initial position that the player started at. When we play the game, the ball is moving in a pretty consistent manner. But we can add some more functionality to make it more interesting, a little bit more fun. So we can add a button press that will launch it forward, that it will give it a little bit of a burst when you press the button. So we'll start by creating an action, a new action for this launch, because it's interacting now with my interfaces and I want to use a left mouse button press to launch the ball forward. So in my inputs folder, right click, input action. We'll call this one IA launch. We'll double click, and because this is a button press, it is an on or off, one or the other, so it's a digital bool value type. The trigger that we want to use is when the button is pressed. Save this, and we'll put this on our IMC ball mapping context. So in our mappings, we can add a second mapping. So if I click the button here and find our launch move that we just created, and for the button, we want our left mouse button. And we'll put this code onto our ball pawn. So let's go find this IA launch event that we just created. So we want our hands action events, and we're going to test this with a print string. And we'll just put launch in here. Compile and save. So now when I press the left mouse button, I should see launch printed to the viewport screen. So we'll close, we'll play, left mouse button, launch. So as I move around the ball, if I click the left mouse button, it's going to launch the ball. And now I need to add some functionality to this so something happens. So we'll go back on our ball pawn, and let's create the functionality for this and then replace the print string. So we're going to need a few more variables. So I'm going to create one variable and call it launch strength. And this will be a float. So this will be the impact of the button press. Compile and save, and let's give it a default of 1000 to start. And then we need a second variable for a vertical hop. This is also a float, but let's put some ranges into our sliders, 0 to 1. And our value range from 0 to 1. Compile and save. And now let's get our IA move. So we want to find our move, and we want to open this up. So we're going to split our struct pin, and then we want to make this a vector 2D. So make vector 2D. And we're going to reverse these so that we actually have our vector moving in the right direction. Then we want to normalize this so that it stays the same in length. And then we want to bring in our vertical hop. So in this case, we want to make our vector here. So our vertical hop is actually going to be our Z. So let's alt click here. And we're going to open up split struct pin and then our X. will go into X, our Y, I'll go into Y, and the vertical hop is going to be our Z. And then we want to multiply this by the launch strength. So we'll bring in our launch strength variable, and that's what we'll multiply by. And then we want to add an impulse to our object. So we'll bring in our sphere. We'll say add impulse. And this information is now our impulse. And we want to check velocity change. And then we're going to remove our print string. And we want to set our physics. So we're going to bring in our sphere again and make sure that physics will influence this. Set all physics linear velocity. So we're going to trigger this and then add the impulse and compile and save and play. And now I see that when I hit the left mouse button, the ball has a little bit of an impulse movement to it, which makes for some more interesting gameplay. So there's one more thing we can add to this, and that would be a cooldown for the launch. So let's go back into our ball pawn, and we'll create another variable, and we'll call this one is launch ready. And we'll make this one a Boolean. And we'll check to make sure that this is on true. So if you check the box, that means this option is a true variable. And then we're going to put this in before it sets the physics. So are we ready for the physics? So let's move this over. And we'll bring in our is launch ready, get is launch ready. And we can create a branch for flow control. So if it is ready, then it will move forward. And then for our impulse, let's add a bit of a delay. So we'll go in here and create a delay node. And for our duration, we will promote this to variable. So we'll create a specific variable for our delay, and we'll call this launch cooldown. So we'll compile and save this, and we'll keep the default at 2. And now we'll see that it'll cool down as it goes, and it'll be ready for another launch, so I can keep launching, and it'll have a little bit of a cool down time. Let's continue to add functionality to the game to make the gameplay more interesting. So one thing we can set up is an object that will be a checkpoint to respawn the player to that particular object's location. So let's do that. In our collectibles folder, right click blueprint class, and we'll create an actor blueprint. Checkpoint, we'll call it BP checkpoint. Open it up, and we'll create an object for this function. So we'll create a cube, and we'll scale it to. We don't need collisions on this object because we're going to have some instructions for the trigger box area. No collision. Then we need a scene component, and we want the utility because we're looking for the locator. And then we'll move this up 100 units so it sits in the middle. And we'll rename this our spawn point. And now we'll add a box collision. And we want the extent to be larger. And we want its location to be up. So now the spawn point is in the center of this box collision. Let's compile and save. And this now will have some coding put in. So when the player overlaps this collision area, this will now become an active checkpoint, and the player will be able to jump back into this area when it respawns. So we'll scroll down, and on component begin overlap, click the plus. And we want to get our player pawn to see if it's overlapped with the trigger box area. So get player pawn. So if our other actor is the player pawn, that's our scenario. Then we want to branch. So we're going to add a branch node because that helps our flow control. So our condition is, did the player pawn overlap this trigger box area? And if yes, we want to get information from the player state. So get player state, cast to our ball player state, so if that's true, then we want to get our spawn point information. So we're going to get our spawn point. So we'll drag in our spawn point, and we want our world transforms. And then we want to set our spawn point. So as ball player state, set spawn point. And we're going to set it to this world transform location. So now let's bring this object into our level, and we'll put it in a couple of spots, one, and we'll put one over here. So now when I go over this area, this box area, if I hit my tab key, I will now checkpoint back to that particular spot. So that was my respawn place. So now if I overlap that area, I will checkpoint back to that spot. So this gives you some pretty interesting abilities to add multiple checkpoints, and we're retaining our collectible count. And we're have the ability to spawn back to different locations. we're going to set up a countdown timer for the lose condition, and that's basically a clock that will count down from a certain number, and when it gets to 0, if the player hasn't achieved the win condition, then the player will lose the game. So we're going to create a game state base for this. So in our blueprints folder, we'll right click blueprint class, and we want a game state base. So we'll choose this, select, and it's BP or ball game state. And we'll double click in here, and we'll create a variable for remaining time. And this will be a float variable. And now we need to go and select this new blueprint in our ball game mode, so it launches it. So our game state, we don't want the generic, we want to use the one we just selected. And in our ball game, we want to add some information here. So in our event graph, on event begin play, so we'll go back to our event graph. We are going to get this game state. So we're going to call this game state. Get game state, cast to, ball game state. And we're going to promote this out pin to a variable. And then we want to add a custom event. And this will be the start of the game. So we're going to call this event. We haven't set it up yet, but we'll do that after we set up the call function. So this is get a reference to our ball game state. So we'll just comment this. And in our start game, we're going to set our timer. So we want set timer by event. And our event is going to be another custom event. So this will be add a custom event. This is update time. And we'll fill that in shortly. And our time, we're going to create a variable. And this is a float. And our default will be 1. And then we want to make sure that this is looping. So we're going to create a scenario where the time counts down, but then it loops back. So it keeps counting down. So every 1 second, it's going to call update time, and then check, and then loop back again. So in our return value, we're going to promote this to a variable. And that's remaining time handle. And we're going to drag in our, we're going to create a variable for remaining time. And we want to set our remaining time. And we're going to promote this variable and cap our game duration. So this will be our game duration length. Compile and save, and we'll set this. We could do 60, but just to test this, I'm going to do 30 here, but we'll set this back to a minute later on. And then we'll bring in our ball game state reference. And we want to set ball game state reference. So now in our update time, we want to subtract a time interval. So we're going to get our remaining time. So we want to get remaining time, and then we want to subtract our time interval. And then that will go in here. So that's how that's going to be calculated. And then we want to get our ball game state. So we want our game state reference. And then we want to stop counting when the counter gets to 0. So we'll add a print string that we'll delete later. And we're going to branch this off. So if our remaining time is 0, that will be our condition. So if our remaining time is less than or equal to 0, then we're going to continue along a pathway. So this will be to lose the game. So if the counter gets to 0, it will print a string to lose or go to a lose screen. So here we're going to pause time. And we need a custom event for that. So this is pause. And then we'll call it here. And pause time is going to look for the remaining time handle. So we want to get our remaining time handle. Pause timer by handle. Compile and save. So we can see our countdown is taking place here. We set it at 30. So when it gets to 0, it should print lose, or whatever is in that print screen, which I don't think I replaced to lose, so I'll go back and do that. So our print screen, pause time, we need to add a print string, and this will say lose. So the timer is kicking in. So now this timer can be put into a widget and eventually into the screens that will navigate the gameplay. So we can create a widget for this. So I'll go into the UI folder, right click, user interface, widget blueprint, and we want a user. We'll call this widget blueprint countdown. Double click. And we're going to add a canvas panel to start. And then we need a text panel. And we'll position this text panel towards the top of the game. So if we position Y here to 100, it's going to move it up. And if we align the X, that'll be towards the center. And then we're going to change this. This is actually, so it will be replaced with the numbers as it counts down. Now in the graph view, we want to get our game state. And then find our ball player state. So we're going to do a casting again. And here we're going to create another variable. Right click. And we'll compile and save this. And now we'll go back to our designer view. And we want to bind to our text. So we're going to look for our text. So we'll select our text and go down and create a binding. And we want to get our ball game state. So we want to get our variable here, get ball game state variable. And then we want to get our remaining time. And then we're going to connect that into this return node. And now we just need to put this new widget into our screen, so that needs to be added to the viewport. So we're going to go into our ball player controller, and we can see that we have add to viewport. So this needs to be at the event begin play, so we can add it after this. So we're going to create widget, create our widget, and we'll find our countdown. And then we want to add this to the viewport. Compile and now we should see the widget blueprint, which has the counter up the top, put the countdown timer in the center as it plays. So it's right up in the center. It's also over here because we didn't. We need to remove the print string. So let's go in to our ball game mode and remove our print string in here for our branch. We don't need this. So we don't need to print it to the viewport. So it's still counting down. So it says lose because that is also a print screen, but that is going to be replaced with the widget, the blueprint widget for a lose screen. So we're creating a lose scenario now, and we also have a win scenario. Both of them are just printing the string because we haven't created the user interface for that. So now that most of the code is done, the level layout, the whiteboxing can be elaborated upon. So I'll just make this a little bit more interesting. The idea is that whiteboxing has the layout with objects that are placeholders, and then they're replaced later on with the models. And you can do some modeling in Unreal Engine, and oftentimes other software packages, Blender, Maya, 3D Max, are used to model final assets and texture final assets. So we can play this now, and it should be a little bit more interesting. We can go in and make our game duration variable. So instead of 30 seconds, let's make it 60 seconds. That's our timer now. And this is our lose condition. So it's still going to print to the viewport the lose and the win scenario. So here's our lose condition. So when the timer gets to 60, if we haven't collected all of the points, then it will print you lose. And our win scenario is on our collectible. So if we collect 13 points, it will go to the win condition. We can set up other win conditions also, and have trigger boxes that will launch the win screen as well. So we're going to create our user interface screens, and then we will replace these print strings. So let's see how well this step plays out. So there's my checkpoint, in case I don't want to have to go back to the beginning. And there's another checkpoint, so that would bring me back, and then so my launch ability has the height, the vertical hop that I can adjust if I wanted to be able to jump up a little bit. So I need one more, and it said win. So that's one scenario. It's posted win, but it didn't launch to the win screen, so we'll fix that. So let's play this again and let the timer beat us out, and it will go to the lose condition. So that vertical hop number can be adjusted initially. So it was set at 0, but it can go up to 0.2, 0.31, and that gives a little bit of a hop here. Three, two, one, and lose. So it's starting to play a little bit more interesting, and then this layout, this whiteboxing layout, would match up with the assets that go into the game. So a very quick comment on materials. Because this is a whiteboxing level, there would not be a lot of material information, but sometimes materials are necessary to see things a little bit better. So we'll create a new folder for materials, and we'll just create one or two. Double click in here, right click, and I want material, and we'll call this M base. So materials can be very computationally intensive. It's best to work with materials as instances. So I'm just going to create a base material, and then I will alter the color or one or two attributes and put them on the objects to make it a little easier to see in my whiteboxing level. So if I look for a constant vector 3 channel, this is X, Y, and Z. So vector 3 has 3 channels, and that would hold the RGB information. And I pull this into base color. I now have the ability to change the color of this material. So whatever this color is here, I can make this a red. And say OK. So now I have a red material. This will update. If I save this, I can assign this material. However, it would be good to assign it as a material instance. So let's do that. To create an instance, anything that you want to show up to be edited must be a parameter. So if I right click here and say convert to parameter, and this is color, I can now save this and close. And then I can right click, create a material instance from this. And it just says base instance. But if I double click to open this, I have access to a global parameter, and the parameter is color. So if I check on this, I can make this color a green and save. And I can do the same thing. So it says material instance, right click, create another material instance. So we'll name them later. If I double click on here, my color can be a different color. So we'll have blue. Save. You can do this with textures. Any attribute on the material can be converted to a parameter. And let's just create a material instance for this color. So we have red, green, blue, and we'll do one more. And we'll make this color a yellow. So we kind of have a range here. And now I want to put the instances onto my objects. And you can just click and drag the onto the object. So we'll do one more. Create material instance. And we'll make this one a darker gray here, darker gray. So if I click and drag this onto my floor, it assigns the material. If I want to go back into my assets, I can assign materials this way. So I can make my collectible a different color. So if we go back into our viewport and we select the cube, remember there was a material slot here. So if we look for, this was M underscore let's see, materials, this was base. So let's look, materials M underscore base. So we want the instance. So we'll make our player red, compile, save. We can make the other collectible. So our checkpoint, we can find a material instance. So our cube is here. And we'll look for M underscore base. And this one can be any one of these colors. So you can update things after the fact. You would replace your models and your materials in these slots for your actors. So you can see it's updated in the viewport. And let's go take the green, and we'll make these panels green. So let's save all and play. And it's a little bit easier to see with values sometimes. My ball pawn is white. Let's go here and let's see if there's a checker material so we can see this roll. So by default, there's a lot of materials that are given to you to use to start with. It's a very interesting process, and it is being updated. So materials, the process of creating and managing materials, will be changed to a new system called substrates, which was formerly strata, which deals with kind of layering of materials. So this is much easier for me to see and navigate around because I can tell what's happening instead of white on white. So that's another thing that you can do as a whiteboxing level. Usually it's just generic shapes and generic colors to get the gameplay functioning. And once the game is functioning, we're going to continue setting up the user interface by adding some screens that will be launched during different parts of the gameplay: win screen, lose screen, instructions, start screen, etc. These screens are created in a 2D software package like Photoshop, a bitmap software package. The size in this case is 1920 by 1080, which is the gameplay screen size, and the format is a PNG file. They can't be viewed on their own. They need to be put into a widget blueprint, and also they need to be connected to a level. So we're going to create first a widget blueprint, WBP, and this is start screen, and we'll just add a few things in here, then connect it to a level. So we need our canvas panel, and then we need an image placeholder. So this box, I can import the images that we created, these images, and I can make this exact 1920 by 1080. And in the brush setting, that's where I'll import the 2D image graphics. So here's my 2D graphic area. And this is a 2D image, but I'm going to add functionality with buttons on top of this. But for right now, I want to compile and save this and create a companion level. So in my maps section, right click and create a new level, and this will be start game. And if I double click to open it, there'll be nothing here because there's nothing in this level. I can set up the widget blueprint in the level blueprint. So open level blueprint. And on event begin play, I'm going to create a widget and add it to the viewport. So create widget, I want to select the widget that I just set up, and we want to add this to the viewport so it can be seen. Add to viewport. And then there's a little mouse cursor fix that we can do. So we want to set show mouse cursor. And this is going to be the player controller. So we want the mouse cursor to be connected to the player controller, and we'll check this box on. Compile and save. So So if we play this level now, we'll see our screen. Nothing's connected yet. We haven't connected any functionality, but we will. So let's go back to our user interface and put some buttons on our start screen now. So I have a button, and I'm going to cover up the word, so I have a range where I can click the button area, and I can change this background color. If I bring the alpha down, I won't have anything covering up my image underneath. And I want to make sure that I check is variable on, because the variables are my events, and it could be either when I hover over with the mouse, something happens, when I click it, when it's released. So you can add some functionality for the button, but it has to be a variable. So on press, when this button is pressed, I want to go in and I want to say open level by name. And what level do I want to open? So this is the start screen, so I want to open my play level. So I will type in ball play, or whatever level I want to get to here. So let's close this and save this. Now if I go back to my start game and play and click the button here, it will bring me into my gameplay level, and I can start to play my game. So all the same functionality is set up here. So that's working. So I need to continue to do this for all the other options and also all the other buttons. So if we go back in here, and then over here there's a quit option and an instruction option. So let's add the quit button. So let's call this one start, and we'll call this button quit. So we'll move this, oops, over the quit region, and we'll change the background alpha, make it a variable, and then when this is clicked on pressed, we want to quit game. And we'll get our player controller, specific player, compile and save. And we have one more. We have instructions. So we haven't set up our instruction widget or our instruction level. So let's do that. So we'll come back to this. So they're all kind of connected to each other. So I will create another widget blueprint, and this will be WBP instructions. And in here, you need a canvas panel and an image. And the same thing, so now we're looking for our instructions texture. So these are our instructions, and we want to call into start, a start button and a quit button, and we can do both of those here. So this is our start button. And we want to make it a variable and bring the alpha down. And on clicked, we want to open level by name. And this is our ball play level, so that's our play level. Compile and save, and now we'll go back to the designer view and add a quit button. Same process. Turn on the alpha, make it a variable, and on pressed, this case we want to quit game. And now we can go back to our start screen and another button for instructions. So we don't yet have a level for the instructions screen. So we'll create that. So we'll compile and save and then come back to this. New level, instructions. And double click, it'll ask to save it. Open level blueprint. Event begin play, create widget. And the widget we want is our instruction screen. Add this to the viewport. So we're going to set our show mouse cursor and get our player controller. And check this on, compile and save. So that's our instruction level. Go back to the user interface. And for our instructions, we have start and quit. But on our start screen, our instruction button, we want to go to the instruction level. So on pressed, open level by name, and the name of this level is instructions. Compile and save. So if we test this, so we'll do our start game. So we're going to launch our start game. Play, so we can start the game. We can quit the game. Or we can go to our instruction screens, and from the instruction screens we can start the game or quit the game. So we're building up our instruction screens, and we need to finish up the remaining ones for our win and lose conditions. So we need the same thing. User interface, widget blueprint, WBP, and we'll call this one win. Double click to open. And canvas panel, image area, (1920 by 1080), and find in our brush. So our win texture. So there's our win texture. And the same thing here. We're going to set up the same buttons. And restart is equivalent to the start. So make this a variable. Bring the alpha down. Compile and save this because we need a win level to hold the win screen. Double click, save selected, and open level blueprint. And event begin play, we're going to create the widget. And this is our win widget. Add to viewport. And just fix the show mouse cursor. Get our player controller, compile and save. Now we can go back and finish up our widget and our restart button on pressed. We want to open level by name. And our level name is our ball play level. Compile and save, and go back to designer view, and our quit button is variable. Bring the alpha down. On pressed, quit game, get player controller, compile and save, and we'll do the same thing for the lose condition. So we need another widget blueprint, WBP lose, canvas panel, image, and there's our lose texture. And we can do these buttons. Bring the alpha down. Check is variable. On pressed. Open level by name. And this is our ball play level. Compile, save. Go back to designer view. Add another button. And we want to quit game. Compile, save. And we need a level for lose. Save this, open the level blueprint, and create a widget. And this is looking for our lose widget, add it to viewport. So we should be able to navigate in and out of the game now, but the next thing we need to do is go in and replace our win and lose conditions with the launching of these screens. So our win condition is on our collectibles. So our print string here, we don't need the print string. What we want to do is we want to open level by name. So if this is true now, we're not going to print win. We're going to open up the win level. So our instructions, so we want to open level by name, and the name is win. Compile and save. And our lose condition is in our ball game mode. So we're going to replace this pause time with open level by name. And we want our lose level. So now if we go back to our maps, we should be able to navigate the entire game. So we'll start the game. So we'll launch start game, and we'll play this. So I can go to my instructions and start, which brings me into my game. So I've lost because the clock ran out, so I can restart now. And now I can win and I can restart. So remember, I have tabs to respawn the player. Lose, and then I can quit the game in any one of these scenarios. So it looks like this is now a functioning game, and the next thing will be to build it out. There's one last thing I need to do before I build that, is to go back into my project settings and now replace my game default map in my maps and modes with my start level. So we want to start game.